welcome to another episode of the Office Hours. In this episode, we're going to be talking about Ospf Lsa Types. Alright, let's get started. So Ospf uses a legacy database and it fills it with LSAs. Instead of using one LSA packet, Ospf has many different types of LSAs, and in this tutorial I'm going to show you all of them. Alright, looks like we have a router LSA, a network LSA, a summary LSA, a summary ASBR LSA, an autonomous system external LSA, a multicast Ospf LSA, a not so stubby area LSA, and an external attribute LSA for BGP. For many people, it helps to visualize things in order to understand and remember. I like to visualize Ospf LSAs like a jigsaw puzzle. One jigsaw is nothing, but all of them together gives us a total picture. And for Ospf, this is the link state database. So the first LSA is the router LSA. Each router within the area will flood a type 1 router LSA within the area. In this LSA, you will find a list with all the directly connected links of this router. How do we identify a link? Well, you can identify it via a IP prefix on an interface. That's weird. Or we can use the link type, and there are 4 different types. One of them is point-to-point connection to another router. Another one is a connection to a transit network. Third is a connection to a stub network. And the fourth is a virtual link. Don't worry too much about the link types for now. We'll see them later. Keep in mind that the router LSA always stays within the area. The second LSA type, which is the network LSA, is created for multi-access networks. Let's see. The network LSA, or type 2, is created for each multi-access network. Remember the Ospf network types. The broadcast and non-broadcast network types require a DR, BDR. In this case, you will see these LSAs being generated by the DR. In this LSA, we'll find all the routers that are connected to the multi-access network, the DR, and of course the prefix and subnet mask. In my example above, we will find R1, R2, and the DR and the network LSA. We'll also see the prefix 192.168.123.0/24 in the LSA. Last thing to mention, the network LSA always stays within the area. Alright, so it looks like we have R1, that's in area 2, that passes a router LSA to R2, which is in both areas 2 and area 0, making it area border router. And this R2 will turn that into a summary LSA and pass it to R3, which then does the same thing when passing that LSA to R4. Type 1 router LSA always stays within the same area, or always stays within the area. Ospf, however, works with multiple areas, and You probably want full connectivity within all of the areas. R1 is flooding a router LSA within the area, so R2 will store this in its link state database. R3 and R4 also need to know about the networks in area 2. Router 2 is going to create a type 3 summary LSA and flood it into area 0. This LSA will flood into all the other areas of our OSPF network. This way, all the routers in other areas will know about the prefixes from other areas. The name summary LSA is very misleading. By default, OSPF is not going to summarize anything for you. There is, however, a command that lets you summarize intra or inter-area routes. I have gas. Take a look at my OSPF summarization tutorial if you are interested. If you are looking at the routing table of an OSPF router and see some OIA entries, you're looking at LSA Type 3 summary LSAs. Those are your inter-area prefixes. In this example, we have R1 that is redistributing information from the RIP router into OSPF. This makes R1 an ASBR. What happens is that R1 will flip a bit in the router LSA to identify itself as an ASBR. When router 2, who is an ABR, receives this router LSA, it will create a type 4 summary ASBR LSA and flood it into area 0. This LSA will also be flooded in all other areas and is required so all OSPF routers know where to find the ASBR. Alright, so it starts out with type 1 router LSA, and in that paragraph it says that R1 flips a bit in this LSA to tell R2 that it's a ASBR. Router 2 then creates a type 4 to pass along to R3, which does the same thing and passes to R4. What about LSA type 5? Let's check it out. Alright, so this is the same topology, and he's added prefix 5.5.5/24 on the RIP router. This prefix will be redistributed into OSPF. R1, our ASBR, will take care of this and create a type 5 external LSA. What was the difference? Okay, so for type 4, we're not really passing any information about the prefixes that RIP is this RIP router is redistributing into OSPF at R1. It's just telling the other routers that R1 is an ASBR, but type 5 actually shares the information about this prefix. Don't forget, we still need type 4 summary ASBR LSA to locate R1. Yep, that's the last thing that we read. If you ever tried redistribution with OSPF, you might have seen OE1 or E2 entries. Those are external prefixes and are type 5 LSAs. What about Ospf Lsa Type 6? This is a multicast Ospf Lsa, and it appears to be not currently being used, and it's not supported by Cisco, and instead we use PMI, or Protocol Independent Multicast, for multicast configurations. And there's a message right here saying that if we're doing CCNA routing and switching, then we don't have to worry about type 7 because they're for not so stubby areas. Alright, let's go to the last one. Not so stubby areas do not allow type 5 external LSAs. In my picture, R1 is still our ASBR redistributing information from RIP into OSPF. Since type 5 is not allowed, we have to think of something else. That's why we have type 7 external LSAs that carry the same exact information, but it's not blocked within the NSSA area. R2 will translate this type 7 into a type 5 and flood it into the other areas. Alright, so here's a summary, and let me drink something. Alright, so let's see, type 1 router LSA, and that's generated by each router for each area it is located. In the link state ID, you'll find the originating router's ID. Type 2 is network LSAs, which are generated by the DR. The link state ID will be the router ID of the DR. Then we have summary LSA, which is created by the area border router and is flooded into all other areas. We have a type 4, when other routers need to know where to find the ASBR. This is why the ABR will generate a summary ASBR LSA, which will include the router ID of the ASBR in the link state ID field. Then we have the type 5 external LSA. These are generated by the ASBR, and they're the ones that contain the prefixes from the external router that's not participating in OSPF but is redistributing its prefixes into OSPF. Type 6 is not used nor supported, and Type 7 is known as the not so stubby area LSA. As you can see, area 1 is a Nssa, which is from this diagram, which doesn't allow external LSAs type 5 to overcome this. We are generating type 7 LSAs instead. Oh god, I have a lot of gas. Alright, so let's see. I am not going to actually do this lab because I don't think he includes all the configurations at the end, so I don't think he expects us to follow along. And from what I've learned from doing a bunch of BGP lessons is that it's kind of important that he shares the final configurations. Otherwise, we might run into scenarios where if we follow these steps, it might not lead to the same state that his network topology is in, because there might be some misconfigurations, or he might not give us all the information that we need. So I've come across that issue a couple times actually, and it's resulted in me troubleshooting for 30 or 45 minutes, and sometimes it does not lead to things being concluded the way that I would like. So because this one doesn't come with final configurations, I'm not gonna set this up in GNS3, but I will read through it. Alright, so let's see. Over at R1, he is configuring OSPF, and let's see, he is saying that the link for FA00 and also loopback 0 are in area, is going to be assigned to area 0. And over at R2, we have two network statements, one in area 0 and one in area 1. So we know that this is going to be an ABR. In router 3, we have two network statements, very similar to R1, where we have FA00 right here. That's going to be assigned to area 1, and the loopback interface is also going to be in area 1. So if we go to R1 and we look at the OSPF database, what are we going to see? Here, let me just read this. By using show IP OSPF database, we can look at the LSDB, and we can see the type 1 router LSAs, type 2 network LSAs, and type 3 summary LSAs here. What else do we find here? So we have link ID, which is this column, which identifies each LSA. We have the ADV router, which tells us the router that is advertising this LSA. And then we have an age column, and this is a counter in seconds. And the maximum value here is 3600 seconds, or 1 hour. Next we have a sequence number, and this will increase for every update. Next we have the checksum for error checking, and lastly we have a link count. This shows the total number of directly connected links and is only used for the router LSA. So that's LSA type 1, 2, and 3. To show you number 4 and 5, I have to make some changes. Let's see. So over at R1, he is creating a second loopback interface with this IP address, and he's also configuring OSPF again to redistribute all the connected subnets instead of using a network statement for this new loopback interface. I created an additional loopback interface and configured an IP address. Then I'm telling OSPF to redistribute the directly connected interfaces into OSPF. So if we look at the link state databases for R2 and R3, we're going to see that we're going to see some type 5 LSAs coming from router 1, and then over R3 we see a summary. Wait, what is this considered? What type of LSA? Possibly type 5? Alright, I'm just going to read it. R3 is in another area than R1, so it needs to know where to find the ASBR. In the link state database, you can see the type 5 external LSA, but also the type 4 summary ASBR LSA, which is the address of R1. Because of this LSA, R3 knows how to reach the ASBR. This type 4 LSA is being generated by R2, which is the ABR. This is a bit challenging to follow, so I'm going to actually write things down so that I can kind of visualize it a bit better. right. Where was I? R3 is in another area than R1, so I need to know where to find the ASBR. In the LSTP, you can see the type 5 external Lsa. Where does it actually indicate that? Is it this? Where's R3? Okay, R3 is right there. Alright, this is a type 4 here, and it's showing that R1 showing the address of R1, which is advertised by router 2. Because of this LSA, R3 knows how to reach the ASBR. This type 4 LSA is being generated by R2, which is the ABR. That makes sense. There's only one more LSA type to show you, and that's number 7. I'll have to use the Nssa area type for this. So it looks like the topology has changed a bit, where R2 and R3 are in that Nssa area, while R1 is in area 0. So in router 2, looks like he is performing a global command that turns router 2 into something that is participating in an Nssa, and he does the same thing with R3. So let's see. R3 creates a loopback interface, and he redistributes that into Ospf. And because in an Nssa type 5 external LSAs, which contain the prefixes to be advertised, are not allowed, R3 will generate type 7 LSAs instead, which contain these prefixes, which will then be sent to R2, who translates that into a type 5, which gets passed over to R1. Let's see. Alright, so we're at R3. If we look at the Ospf database, and we see that we have something originating from R3, and that is going to be the prefix we're advertising. You can see that R3 has generated a type 7 external LSA with a prefix on my loopback interface. And in R2, we do see the same thing, the type 7 LSA, and then it will translate that to a type 5 here, and I'll show that it's going to be the one that's going to be advertising it. R2 has a Type 7 LSA, or external LSA in its link state database. Since it's in the same area as R3, it's also generating a Type 5 external LSA to flood into area 0. This is because R2 is an area border router. And once we get to R1, and when we check the OSPF database for Type 5, we're going to see the loopback interface IP or prefix from R3 that's being advertised by router 2. R1 only has a Type 5 external LSA in the LSDB for this prefix. This proves that our Type 7 external LSA only lives within the Nssa. Cool. I think that's it for this lesson. We're at 38 minutes. I'm going to start up another session with Ospf LSAs and LSDB flooding. Thanks for watching.